Hello everyone, welcome to the another lecture of the periodic table class 9, myself Suman Singh. So in the last class we have discussed about the modern periodic table and their merits and demerits, right? So now and also we talk about the periodicity. So in today's class we will see the general trend of modern periodic table, okay? So what is the general trend of modern periodic table? So first is the number of cells and the valence electron. So I hope you know what is number of cells and what is valence electron, right? So suppose this is a nucleus here. So this one is first cell, this one is second cell, this one is third cell, and suppose in the third cell there are two or three electrons. So this is called valence electron, the electron which is present in the outermost cell, right? So when we talk about the number of valence electron, so number of valence shell increases automatically and the number of valence electron remain equal to the number of group to which the elements belong. Okay, means what? Suppose you can take the example like this. You can take the example of lithium, sodium, okay, and potassium. So when you will see the electronic configuration of lithium, it will be 2 and 1, right? And here is 2 8 and 1, and here is 2 8 8 and 1, right? So as you can see, as we are going down the group, so you can see the number of cells are increasing automatically, right? Here 2 cells only, here 3 cells, here 4 cells, right? So as you can see, number of cells are increasing, right? But as you can see, number of cells are increasing, but the valence electron remain equal. As you can see, valence electron is same, right? Valence electron is same, right? So I hope you have understood this. So what I mean to say that the number of cell increases automatically and the number of valence electron remain equal to the number of group to which the elements belong, okay? And also what we can say, the number of electrons, the number of electron cell is in a given element is equal to the is equal the number of a period to which it belongs. As you can see, I will give you one more example. So as you can see, this one, the example of this. So here you can see that it is the element here, it is fluorine, chlorine, bromine, iodine and astatine, right? So when you will see the number of cells equal to the number of period, so you can see fluorine second period, fluorine third period, fourth period, fifth and sixth period, right? Now again, when you will see the electronic configuration of these elements, so you will see that in the outermost cell they have a same number of electrons, right? So what I mean to say that the number of electrons and the number of electron cell is in a given element, the number of electrons in a given element equal to the number of period, okay, is equal to the number of period to which it belongs, okay? One more thing, I will give you one more example to understand it clearly. So for this we will go to the periodic table. So as you can see in this periodic table, so when you will see, leave about okay, we will see from hydrogen. So hydrogen and helium, okay? So when we see the electronic configuration of hydrogen, it is only 1s, right? 1, okay? And for helium it is 2, right? So how many cells are there? Only one cell is there, right? So only one cell means it belongs to first period, okay? It belongs to first period, okay? Now when we talk about the lithium or beryllium, lithium, so it has electronic configuration of 2 and 1, right? And beryllium has a electronic configuration of 2 and 2, right? So how many cells? 1 and 2 cells, right? 1 and 2 cells, right? So as you can see, how many in which period it belongs to second period, right? So now again, when you see the example of, when you see the example of boron, or let us take the example of neon also, okay? So neon has 10 electrons, so its electronic configuration will be 2 and 8. How many cells? 1 and 2 cells, right? So that is why it belongs to second period, right? Now one more example we will see, the example of suppose potassium, okay? As you can see the example of potassium, which is K, okay? So its electronic configuration will be 2 8 8 and 1, right? 2 and 8 10 10 18 plus 19, right? So how many cells? You can see 1 2 3 and 4 cells, right? So it belongs to fourth period. As you can see, 1 2 3 and 4, it belongs to fourth period. So I hope you have understood this, right? Now next we will see the valencies. Okay, so when we talk about the valency, I hope all of you know, right, how to find out the valency. So valency of an element is what? It is equal to the number of electron present in the valency of an element is equal to the number of electrons present in the valence shell. Okay, since elements in a particular group has an equal number of electrons in their respective valence shell, so valency of an element in a given group is same. Okay, so what does it mean? What it has been told that valencies of an element is equal to the number of electron present in the valence shell. The means what? The valency will depend on the number of electrons present in the valence shell or in the outermost shell. Okay, means what? Number of the amount of electron present in the valence shell, it will decide the valency of an element, right? So you can see that some of the elements will have a same number of electrons in their valence shell, so at that type of element will show a same valency. Okay, for example, you can see the example of lithium, sodium and potassium. So when you will see the example of lithium, sodium and potassium, you will see that the electronic configuration of lithium is 2 1, sodium is 281, and the potassium is 288 and 1, right? So at that time when we talk about the, now since you can see number of valence electron is same, right? One here, one here and one here also, right? So since the number of valence electron is same, so its valency will be same. Okay, as you can see, 1 1 and 1, right? So some more example is given, as you can see. Now this is what we can see. We can easily identify the valency of an element. So I will give you one formula. Suppose if the period is valency of the group 1 2 and 3. Okay, if you will take the group 1 2 and 3, they will have a valency of 1 2 and 3, right? And from group 4 to from as you can see, valency of group 1 is 1, 2 is 2 and 3 is 3, right? But the group number after that, the group number 13, when we talk about the group number 13, it will be 13 minus 10, it will be 3, right? And the valency of group so as you can see, the valency of group 13 is what? 13 minus 10, 3. In the same way, valency of group 14 will be 14 minus 10, 4. In the same way, valency of group number 15 will be 18 minus 15, which will be 3. And after that, group 16 will be, and group 16 will be 18 minus 16, it will be 2. And for group 17 it will be 17 minus 18, as 18 minus 17 it will be 1, right? And for valence for group 18, or we can say 0 group has 0 valency. Okay, one more method is there. One method is like this: if the number of electrons present in the valence shell is 1 2 and 3, so at that time their valency will be 1 2 and 3. Okay, and after that, if the valence electron if the number of electron in the valence shell is 5 6 7 or 8, at that time the valency for 5 will be 8 minus 5, which will be 3. Okay, for 5 the valency will be 3. For 6 it will be 8 minus 6, which is 2. Okay, and for 7 it will be 8 minus 7, which is 1. Okay, and if the number of valence electron is 8 in its outermost shell, it will be 0. So I hope you have understood this, right? If it is number of electrons in the valence shell is 5, if it is 4, then 4, it will valency will be 4, because 8 minus 4 is 4, right? So if there is 5 electron in his valence shell, or 6 or 7 or 8, at that time it will be 8 minus 5, 8 minus 5, it will be 3. The valency will be 3 for this. And for this 8 minus 6, it will be 2. And for this 8 minus 7, it will be 1. And for this 8 minus 8, it will be 1 0, right? So in this way also we can find out the valencies of a particular element. Okay, so I hope you have understood this, right? Next is properties of element. So when we talk about the properties of elements, so elements in a given group possess a similar electronic configuration, right? And because of the number of electrons in their respective outermost shell is same, right? So hence what we can say, they have a very similar physical and chemical property which changes uniformly down that group. Means what you are what here what he wants to say, that if we are moving from lithium, if we are moving from lithium, sodium, potassium, rubidium, right, cesium and francium, at that time you will see that the number of electrons present in the outermost shell is 1, right? For every, for sodium, potassium, rubidium and cesium, you will see that the number of electrons present in the outermost shell is 1, right? So since the number of electrons present in the outermost shell is 1, so that is why what will happen, they will possess a very similar physical and chemical property, right? And which will change uniformly down the group, right? So I hope you have understood this, that element in a given group, when you talk about the group, will possess a similar electronic configuration, right? 281, 2881, right? This, right? So because of the number of electrons in their respective outermost shell is same, so what we can say, they have a very similar physical and chemical property which changes uniformly down the group, right? Now next property is, for example, as you can see, one example is very nice example is given here. As you can see, when we talk about the alkali metal, which is a group 1 metal, right? So they are very reactive, right? So and a decrease decrease in reactivity further increases down the group. Means what? Means what? If we are moving from lithium to sodium, after that potassium, rubidium and cesium, so the reactivity will increase, okay? The reactivity will increase when we go down the group. When you will go down the group in a group 1 alkali metal, as you go down the group, means what? Lithium will be less reactive than sodium, sodium will be less reactive than potassium, potassium will be less reactive than rubidium will be less reactive than cesium, and cesium will be less reactive than francium. Means what? More francium is very reactive, after that cesium, after that rubidium, after that potassium, after that sodium and after that lithium. Means francium will be more reactive, after that, after the cesium, after that rubidium, after that potassium, sodium and lithium, right? So I hope you have understood this. So reactivity will increase as we move down the group. Means what? Lithium is less reactive than francium, sodium is less reactive than cesium, potassium is less reactive than francium. Like this, the reactivity will increase as we move down the group, right? Now one more example is given here, halogen. When we talk about the halogen, which is group 17, the fluorine family, okay? So when you will see the reactivity of a fluorine, sorry, for halogen atoms, which is the fluorine, chlorine, bromine, iodine and acetylene, right? Fluorine, chlorine, bromine, iodine and acetylene. So at that time you will see that the halogen atom also has a very high, very are very reactive, right? But their degree of reactivity decreases as we move from fluorine to iodine. Means what? When you will move from fluorine to iodine, the reactivity will decrease, okay? In the alkali metal, what we have seen, when we are moving down the group, the reactivity was increasing, right? But when you will see in the halogen family, the reactivity will decrease as we will move from, so fluorine to iodine, right? As you can see, the reactivity is decreasing as we are moving from fluorine, chlorine, bromine to iodine. Means fluorine is more reactive than iodine, chlorine is more reactive than iodine, bromine is more reactive than iodine. So if you will compare this to, fluorine is more reactive than chlorine, chlorine is more reactive than bromine, bromine is more reactive than iodine, right? So the reactivity will vary like this. So I hope you have understood this, right? Now next, when you talk about the atomic size, so there will be a change in the atomic size, as you will see, as one move down the group, right? The size of the atom successively, or the size of atom of successive element increases, right? And this is because of the progressive increase in the number of cell, right? So for example, what we can say, when we'll talk about the lithium, sodium or potassium, so for lithium, the like this structure was there, right? This was nucleus, this one is first cell and this one is second cell, right? So for this, the structure was like this. Now for sodium, when you will see, for sodium the structure was like this, right? For sodium we can draw like this: first nucleus, first cell, second shell, okay, like this, right? Two, first cell, second cell, okay, and third cell here, like this, right? And for potassium, I'm drawing here. For potassium, suppose this is a nucleus here, and this is the first cell, and this is the second cell, and this is the third cell. So as you can see, as we are moving down the group, the number of cells are increasing, right? Here only two cells were there, here it has become one, two, three cells, here it has become four cells, like this, right? As we move down the group, the number of cells is increasing, like as you can see here as you can see, in lithium there is only one and two cells, right? But in when you have come down to sodium, the cell number of cells increases to three, okay? And after that, when you have come out for potassium, the number of cells again increases to four. Now when we talk about the rubidium and rubidium, cesium, and rubidium and cesium, the number in rubidium the cells is increases to 5, and cesium it has increased to 6, right? So what we are seeing here, that as we are moving down the group from lithium to sodium, from sodium to potassium, potassium to rubidium and cesium, the number of cells are increasing, right? As you can see, number of cells are increasing. In the first case, there was in lithium there was only two cells, okay? In lithium there was only two cells. Now in sodium it has become three, in potassium it has become four, and for rubidium it has become five, and cesium it has become six. Means what? The number of cells are increasing, right? So as the number of cells are increasing, the number of the size of the atom will also increase, right? So what we can say, as one move down a group, the size of the atom is the size of atoms of successive element increases, right? So this is because of progressive increase in the number of cells. As you can see, there is an increase in the number of cells, that is why there is a increase in the size of the atom. So what we can say, in group 1, atomic size increases as one move from lithium to cesium, right? Because the number of cells are increasing, that is why what we can say, in group 1 the number of and the size of the atom is increasing as we are moving down the group from lithium to cesium, right? So I hope you have understood this, right? Now next is metallic characters. So metallic character is very interesting, as you can see. So metallic character increases, okay, as one move down the group. For example, in group 15, when you will see in the example of group 15, which is a nitrogen family. So when you will see nitrogen, phosphorus, after that arsenic, after that antimony, bismuth, okay. So at that time you will see that group 15, in group 15 nitrogen and phosphorus are non-metallic, right? And arsenic and antimony are metalloids, whereas bismuth is a typical metal. So as you can see, metallic character is increasing as we move down the group, right? For means what, when we are moving down the group, the metallic character is increasing. As you can see, in for example of group 15 is given. So in group 15 you will get five elements, which is nitrogen, phosphorus, arsenic, antimony, and bismuth, right? So here you will see nitrogen, phosphorus is completely non-metal, okay. After that, when we talk about the arsenic and antimony, it is a metalloid. It is a type of metalloid. So when you will see the metalloids are something like, you can see boron is a metalloid, silicon is a metalloid, germanium is a metalloid, arsenic is a metalloid, antimony is a metalloid, okay. After that, polonium is a metalloid, okay. Tellurium is a metalloid. So this one, arsenic and antimony is also a metalloid, okay. But when you will see the bismuth, it is a typical metal. So what we can say, as we move down the group, the metallic character increases, right? Now one more thing is given. It is on account of gradual increase in the metallic character of an element from top to bottom. Their oxides of element become increasingly basic in character on moving in the same direction. Means what? As we have seen, what, when we are moving from down the group, metallic character increasing, right? But as the metallic character is increasing, but when we talk about their oxides, the oxides will become more and more basic as we will move down the group. Means what? The oxides of bismuth will be more basic, than the oxides of antimony, okay? Or we can say the oxides of nitrogen will be more acidic than the oxides of bismuth, right? I hope you are understanding that. Means what? As you can see, the example is here, right? As you can see, this is what, this is an oxide of nitrogen, this is an oxide of phosphorus. After that, this is an oxide of arsenic, and this is an oxide of antimony, okay? And after that, this is an oxides of bismuth. So as you can see, when we are moving down the group, their oxides becoming more and more basic. This is the basic, this is amphoteric, means both will have, it will show both the character of basic as well as acidic, and this is purely acidic. So what we can conclude here, when we move down the group, okay, in group 15, when we're talking about the group 15 elements, when we are moving down the group like this, from nitrogen to phosphorus, and after that arsenic, antimony or bismuth, at that time the basic character is increasing. Means what? The oxides of bismuth will be more basic than the oxides of this nitrogen and phosphorus. Means what? Nitrogen and phosphorus oxides will be acidic in character, but the oxides of bismuth will be basic in character, okay? And when we talk about these metalloids, arsenic and antimony, their oxides will be amphoteric in character, which will be so both acidic and basic as character, right? So I hope this one is also you have understood. Now next is, there is a note is given. As you can see, hydrogen has been placed at the top of the group 1, right, above the alkali metal of that group, because the electronic configuration of hydrogen is similar to those of the alkali metal. But both hydrogen and alkali metals have one valence electron, right? However, hydrogen atom is a very small in size, and therefore many of its property many of its property are different from those of the alkali metal, such as such, while discussing the alkali metal of the group 1, hydrogen is ignored. However, in some periodic table, hydrogen is not placed in any group. It is treated as a very special element and thus placed along the head of the periodic table. What does it means to say that here the place of hydrogen in most of the periodic table, you will see that the place of the hydrogen has been placed on the top of the alkali metal, right? Hydrogen is placed on the top of the alkali metal, because when you will see the electronic configuration of hydrogen, it is only one, right? So but when you will see the lithium or sodium, so lithium and sodium, lithium is 2 and 1 and sodium is 2 8 and 1. So as you can see, one electron in the outermost cell. So that is why in some of the periodic table you will see that the hydrogen is placed just above the alkali metal. But you will see, because they have a similar electronic configuration, but both the hydrogen and alkali metal has, because both the hydrogen and alkali metal has one electron, one valence electron, right? As you can see here, one valence electron. But if you are talking about the hydrogen atom, its size is very small, right, as compared to the size of the alkali metal, which is lithium, sodium and potassium. The size of the alkali metal is very small. So therefore what will happen, so most of the properties of hydrogen will be different from the alkali metal, okay? So what we can say, that while discussing the alkali metal of group 1, most of the time hydrogen is ignored, because um, it does not resemble all the properties which is shown by the alkali metal, right? So that is why in most of the cases, when we are discussing alkali metal, hydrogen is ignored. However, when if you will see in some of the periodic table, hydrogen is neither placed in the group 1 or nor it has been placed in the group 17. It has been placed on the top of the periodic table, right? So because this is a very special type of element whose property is, it will sometime it will show the properties of alkali metal, which is group 1, and sometime it will show the properties of group 17, which is halogen family. So that is why in most of the periodic table you will see that hydrogen has not been given in a proper place. It has been placed on the top of the periodic table, okay? So I hope you have understood this. Now, number of cells. When you talk about the number of cells, so we all know that on moving left to right in a given period, number of cells remain same, which I have given you example, right? That number of cells will decide the period of that element, right? So as we can see, on moving from left to right in a given period, the number of cell remain same, okay? For example, in third period, the number of cell remain 3, which is equal to the number of period. Just now I've given you the example, right? So as you can see, group 3 example is given for third period. Element of third period is what? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So when we will see the atomic number of sodium is 11, 12, 13, 14, 15, 16, 17, and 18, right? So now we will see the electronic configuration. There are three cells. Number of cells are same, right? Number of cell is same. So number of cells define the period of the element. Suppose this is number of cell is 3, so it belongs to third period. Number of cell is 3, it belongs to third period. Number of cell is 3, it belongs to third period. Number of cells is 3, as you can see out, it belongs to third period, right? So I hope you have understood this. So next is number of valence and number of electrons in its valence cell. So in a given period, the number of electrons in a valence cell increases from left to right, right? As you can see here, the number of electrons in the valence cell is 1. As we have moved to magnesium, it has increased to 2, then it has increased to 3, 4, 5, 6, 7, and at last 8, right? So as we are moving from left to right in a period, the number of valence shell, not every shell, only the valence shell electron is increasing. As you can see, this is the valence shell for this is the valence shell of this is the valence shell of this, right? So as we are moving from left to right in a period, number of valence shell is increasing. As you can see, which is the valence shell here? This one. For this, the valence shell is this. For this is this. For this is this one, this one, this one, this one, and this one, right? So as you can see, then as we are moving from left to right, this one is left side, this is the right side, right? So as we are moving from left to right, number of valence cell is increasing. As you can see, from 1 it has become 2, 3, 4, 5, 6, 7, and 8, right? Now next is valency. So valency of an element with respect to hydrogen increases automatically from 1 to 4 and back to 1. Means what? If you will take the with respect to hydrogen, if you will compare the valencies with respect to hydrogen, it will first decrease from 1 to 4, like 1, 2, 3, 4. After that it will be 3, 2, and 1. It will come like this, right? So I have given you one example also, right? 8 minus like this. So as you can see, some of the hydrides, the valencies of some hydrides. So lithium, if we are talking about the hydrides of lithium, its valency with respect to hydrogen is 1. Beryllium, when you talk about the valency hydrides of beryllium with respect to hydrogen is 2. For boron is 3, and for carbon it's 4. For nitrogen is 3 again. For hydrogen 2, and for oxygen 2, and for fluorine 1, right? As you can see, hydrides are increasing, right? First of all, it has been increased. Valency is increasing from 1 to 3 and 4. After that it is decreasing to 3, 2, and 1, right? Now, but valencies of the element with respect to oxygen will increase from 1 to 7, but it is not same in if we are comparing the valencies of the element with respect to oxygen, it is not following that trend. It is following just like the simple 1 to 7. It will increase. So as you can see, with sodium, with sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. So when you will see the oxides of this element, you can see this is the oxides of this element. So when you will see the valencies with respect to oxygen, it is increasing. It is not like this, right, in the same way, but here it was different, right? As you can see, in case of hydride it is 1 2 3 4, after the 3 to 1, but in case of oxides it will increase from 1 2 3 4 5 6 7, right? So I hope you have understood this also. Now next is size of atom. Now next is size of atom. When we talk about the size of atom, as I have already told you, the size of atom decreases while moving from left to right in a period. Always remember that if we are going down the group down the if we are going from left to right across the period like this period, it is no, we are not talking about this, sorry, it is we are not talking about this group, right? We are talking about the period. So when we go across the period from left to right across the period, at that time what will happen, you can see the size of atom decreases while moving left to right in a period. Why it is happening? Because of the increase in the number of protons, right? Increase in the number of protons increase the nuclear pull, which decreases the size. Thus in a particular period, alkali alkali atom has a larger size and halogen atom has a smaller size. Let me tell you, explain you this one. So as we have seen that when we are moving from left to right in a period, okay, when we were moving left to right in a period, I will give you example from here, you can understand. Let me, yes, from here you will see. So this is what it is across the period, right? So when you will see, when you are moving from across the period, number of cells remain the same, right? You can see number of cells is remaining the same, right? Number of cell is remaining the same, but you will see that the number of charge, means the nuclear charge, or we can say the number of protons is increasing, as you can see here, right? Number of cells is remaining same, number of cells remains same, right? But the number of electrons and protons are increasing as we are moving from left to right in a period, right? So since the number of electrons and proton is increasing here as we are moving from left to right, the number of proton is increasing, means the charge on a nucleus is increasing, right? So since the charge of a nucleus will increase, then what will happen at that time? The size of the atom will decrease, right? As you can see in this map, from here you can easily understand. As you can see what is happening here, so this is what nucleus, this is nucleus, right? So this is what, this is a nucleus, right? This is what, this is nucleus, right? This is nucleus, this is nucleus, this is nucleus here, nucleus and nucleus, right? So here you will see that this is also nucleus and this is nucleus. So number of cells is remain same, right? You can see 2 2 2 2 2 and 2 and 2, right? Number of cells is same, right? But you see that the nuclear charge, number of nuclear, means the number of proton is increasing, proton electron is also increasing, but the number of as well as proton is also increasing. So since number of proton is increasing, then what will happen? The nucleus will attract this the nuclear will add more attract this outermost cell towards itself, right? So as the number of charge is increasing, so what will happen? The nucleus, what will it will do? It will pull the electrons toward itself. Since it is pulling the electrons, outermost cell towards itself, or we can see that since it is pulling the electrons toward itself, so what will happen? The size of the atom will shrink, right? Or we can say that the size of the atom will decrease, right? As we are moving from left to right in a period, right? So I hope you have understood this, right? So let me explain you in another way. Since we know that as we are moving from left to right in a period, the number of cells is increasing, right? As number of cells remain the same, but since number of cells remain same, but the atomic number is increasing, right? As you can see, since the number of number of cell is remaining same, but the number atomic number is increasing. Since atomic number is increasing, means number of proton and electron is increasing. Since the number of proton is increasing, what will happen? The nucleus in the, where this proton exists in the nucleus, right? So since the number of proton is increasing, there will the proton will exert more force on the electron, and it will pull towards itself, right? What it will do, since proton is positive charge and electron is negative charge, so what will happen? This proton will pull this electron towards itself, right? So as the number, as the charge of the proton, or we can say that the charge on the proton is increasing as we are moving from left to right in a period, so what will happen? What this proton will do, it will attract more and more electrons towards itself. Since it is attracting more and more electron towards itself, what will happen at that time? The size of the atom will decrease, right? So I hope you have understood this, right? Now, properties. When we talk about the properties, so properties, actually it will depend on the, what I have already explained you, it will depend upon the number of electrons in the outermost orbit, right? Properties will depend on the number of orbits or number of electrons in the outermost orbit, means it will depend on the valence shell or valence electron, right? So since in period the number of electrons in the valence shell changes, right? You will see in we have seen that in period the number of cell is remaining same, but the number of electrons is changing in the valence shell, right? For sodium, the number of electron in the valence shell was 1. For magnesium it has become 2. For aluminum it has become 3. For silicon it has become 4. For phosphorus it has become 5, right? So since the in a period, when we move across the period like this from left to right in a period, so what will happen at that time? The number of electrons was increasing in the valence shell, right? So since the number of electrons in the valence shell changes, the properties of the element in a period differ significantly. Since the number of electrons was changing, so that is why the properties of the element across the period will change. Okay, but when we talk about the group, in group, when we are talking about the group, and as we are moving from top to bottom and moving down the group, you will see that the number of valence electron remains same. That is why their properties was same. But in period it is not like this, because in period, as we will move from first to second or third to fourth period like this, as we are moving from left to right, the number of electrons is changing from 1 2 3 4 5 6 7 and 8, right. The number of electrons in the outermost cell is changing like this. So since the number of electrons is not same across the period, right, or moving from left to right in a period, number of electrons in the valence cell is not same. That is why the properties of this element will be different, right. So for this, one example is given that reactivity first decreases up to group 14 and then increases. This one means what? If you will move from left to right in a period, okay, if you will move from left to right in a period, what will happen? You will see this. Here you can see this. You get from here, right? You can see, as you can see. So if you are taking the example of a group, if you are moving from here to here, right, here to here, if you are moving like this, so at that time you will see that the reactivity, when you talk about the reactivity, it will first decreases up to group 14. Means what? If you are moving, suppose if you take the example of this potassium, calcium, scandium, titanium, vanadium, like this, or if you take the example of this sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon, when you are moving like this, okay, from here to here, so at that time what will happen? The reactivity first decreases up to group 14. Means what? From here to from here to here, this is group 14, right. So up to this, the reactivity will decrease, okay. After that, the reactivity will increase, okay. From here to here, reactivity will increase, but here to here, the reactivity will decrease. In the same way, if we are moving from here to here up to this, the reactivity will decrease, okay. The reactivity will decrease, and after that, from here to here, the reactivity will increase, right. So I hope you have understood this, right. Now, thus group 1 element are more reactive metal, while those of the group 17 are more most non-reactive metal, right. What we can say, that in this way, what we can say, this group 1 element is a more reactive metal, and this group 17 element is a more reactive non-metal, right. So I hope you have understood this. Now next we will see, the next example is metallic character, okay. Here, metallic character. So for this also we have discussed, right, on moving from left to right in a given period, metallic character gradually decreases, okay. It changes from metallic to non-metallic. Just what it was happening, it was first changing from metal, and after that it is changing into non-metal, right. So it was changing from metal to non-metal. For example, you can see, when we are moving from in the when we are talking about the first period, okay, the second period, so it is lithium and beryllium is metal. After that, when you will see boron, it is a metalloid, and after that, from carbon, nitrogen, oxygen and fluorine, it is all are non-metal, right. So as you can see, example is given, lithium and beryllium is metal, okay, boron is a metalloid, and after that, these three are non-metal, right, and this is the noble gases. So I hope you have understood. Now again, oxides, as we have already discussed. So oxide will change. No, oxides is not like this. It will go on increasing, right. So oxides of element in a particular period become progressively less basic and finally changes to acidic character. For example, as you can see, consider the oxides of the third period of the element. As you can see, the acidic character increases. This one will be more acidic than this one will be more acidic than this one will be more acidic than this one is more acidic than this one is more reactive than more acidic than this one is more acidic than this. So as you can see, as we are moving from left to right across the period, for when we're talking about the third period, so sodium oxide, here magnesium oxide, aluminum oxide, silicon oxide, okay. After that, phosphorus oxide, sulfur oxide and oxides of chlorine. So here you can see the acidic character is increasing. Means what? This one is more acidic than this one is more acidic than so the SID character is increasing, right? So I hope you have understood this. So I think the trend you have understood, right? So I think today's class you have understood. So keep up to this, okay? And try to go through this because it is very difficult. I know it is very difficult to understand in one go. So you just go through the book, okay? Try to read this, okay? So if you will have any doubt, so let me know in the comment section, okay? So keep up to this. In the next class we will discuss about the group 1. We will study the group separately, just like group 1, group 2, group 3, like this we will learn separately, okay? So keep up to this. Till that, thank you.